Good day everyone, welcome to our discussion on the topic calculus. Calculus, originally known as infinitesimal calculus, is the branch of mathematics that deals with the study of continuous change. It is divided into two broad branches, differential calculus and integral calculus. Differential calculus is the study of instantaneous rate of change and the slope of curves, while integral calculus is the study of accumulation of quantities and the area under and between curves. Some of the prerequisites to this course is knowledge in coordinate geometry, function, limit, and trigonometry. In this class, we concern ourselves with the study of differential calculus, more specifically the first principle of differential calculus. For the first principle of derivative, consider a function y equals to f of s. If we plot this function on a Cartesian coordinate and choose 2 points A and B with coordinates being s1 and y1 for A and the coordinates of B being s2 and y2, from our knowledge of coordinate geometry, M will be equals to the increase in y divided by the increase in s, which is equals to y2 minus y1 divided by s2 minus s1, with y2 minus y1 being the change in y or delta y and s2 minus s1 being the change in s or delta s. This will be our equation 1. Now from equation 1, s2 will be equals to s1 plus delta s. Obviously y is a function of s, so therefore y1 will be a function of s1, that is y1 will be equals to f of s1, and y2 will be equals to f of s2. This will be our equation 2. Now substituting for s2 in equation 2, that is substituting s2 to be equals to s1 plus delta s, y2 rather becomes f of s1 plus delta s. This will be our equation 3. Now substituting for s2 minus s1, y1 and y2 in our original equation, m will be equals to f of s1 plus delta s minus f of s1 divided by delta s. As the distance between A and B reduces, that is, as B gets closer and closer to A, the equation becomes m equals to f of s plus delta s minus f of s divided by delta s, because the value of s1 and s will almost be the same. That is, as B gets to A, the value of s and s1 will be almost similar. Now from our graph, we can see that as B gets everly closer to A, that is, as B tends to A, change in y over change in s will be equals to dy over ds, that is the slope of the tangent through A. Therefore, dy over ds will be the limiting value of change in y over change in s, or the limiting value of delta y over delta s. That it will now be equals to the limiting value of f of s plus delta s minus f of s divided by delta s. Derive definition form of first principle. Now still considering the function y equals to f of s, this will be our equation 1. Deduction from the diagram, we know that for every increase in s or every change in s, that is delta s, there is a equivalent change in y or delta y. That is, y plus delta y will be equals to f in brackets s plus delta s. Let this be our equation 2. Now at this point, we are going to subtract our original equation for delta 2, or simply put, we can either subtract y from both sides or subtract y from the left hand side and subtract f of s from the right hand side, because y is equals to f of s and the equation will still be balanced. either way it will still be correct. So subtracting equation 1 from equation 2, y plus data y minus y will be equals to f of s plus data s minus f of s. This makes our equation, the left answer will be data y because y and minus y will cancel out, and the right hand side will be f of s plus data s minus f of s. Remember, we are trying to find data y over data s. So dividing through by data s, our equation becomes data y divided by data s will be equals to f of s plus data s minus f of s divided by data s. So taking limit as data s tends to 0, the y over the s will be equals to the limiting value of data y over data s as data s tends to 0, which is equals to the limiting value of f of s plus data s minus f of s divided by data s as data s tends to 0, which is similar to what we've got from our deduction earlier. This is known as the derived definition of dy over ds. We have some examples we are going to attempt using first principle. The example states that find the derivatives of the following with respect to s using the first principle. Number 1, s squared, and number 2, 2s squared plus s plus 2. Attempting number 1, the first thing we are going to do is write down our equation. Y will be equals to s squared. This will be our equation 1. And recall, for every change in y, there is a corresponding change in s. So therefore, y plus data y will be equals to s plus data s in brackets squared. Now subtracting equation 1 from equation 2, we get y plus data y minus y will be equals to s plus data s in bracket squared minus s squared. For our left hand side, y and minus y will cancel out and we are left with data y. And on our right hand side, we first have to expand our bracket s plus data s squared. Expanding the bracket, it gives us s squared plus 2s data s plus data s squared. So our equation becomes data y equals to s squared plus 2s data s plus data s in bracket squared minus s squared. S squared and minus s squared will cancel out. Our equation further simplifies to data y will be equals to 2s data s plus in brackets data s squared. At this point, we are going to divide both sides with data s, because originally we are looking for data y over data s, so we can in extension find dy over ds. Dividing both sides by data s, data y over data s will be equals to 2s data s divided by data s plus data s in bracket squared divided by data s. 2s data s divided by data s will be equals to 2s, and data s in bracket squared divided by data s will be equals to data s. So our equation still further simplifies to data y over data s will be equals to 2s plus data s. So at this point, to find dy over ds, we'll find the limiting value of data y over data s as data s tends to 0. So dy over ds will be equals to the limiting value of data y over data s as data s tends to 0, which is equals to the limiting value of 2s plus data s as data s tends to 0. As data s tends to 0, ds will be equals to 0. So the ds part of our equation will cancel out or become 0, and we are left with 2s as our final answer. So dy over ds will be equals to 2s. The other method we can use to approach this is to impute our function in the formula directly, and we know by deduction that dy over ds is equals to the limiting value of f of s plus data s minus f of s divided by data s. Now let f of s be equals to s squared. F of s plus data s will be equals to s plus data s in bracket square. Substituting directly into the equation, the y over the s will be the limiting value of s plus data s in bracket square minus s square divided by data s. Simplifying the bracket in our left hand side by expanding it, it becomes the limiting value of s square plus 2s data s plus data s square minus s square divided by data s. Simplifying the numerator, s square will cancel out minus s square. We are left with the y over the s equals to the limiting value of 2s data s plus data s square divided by data s, as data s tends to 0. Dividing by data s and splitting the expression into 2s data s divided by data s plus data s square divided by data s, it becomes the y over the s will be equals to the limiting value in bracket 2s data s divided by data s plus data s square divided by data s. 2s data s divided by data s will be equals to 2s, and data s square divided by data s will be equals to data s. So we are left with the limiting value of 2s plus data s as data s tends to 0. As data s tends to 0, data s will be equal to 0, so data s will cancel out and we are left with the y over the s is equals to 2s. For our example 2, y is equals to 2s square plus s plus 2. This will be our equation 1. And we know that for every change in s, there is a corresponding change in y. So y plus data y will be equals to 2 in bracket s plus data s close bracket squared plus s plus data s in bracket plus 2. That's everywhere we have s on the left hand side, we added plus data s. Now expanding our bracket s plus data s square, it becomes s square plus 2s data s plus data s square. So our expression becomes y plus data y equals to 2 in bracket s square plus 2s data s plus data s square plus s plus data s in bracket plus 2. Now simplifying the right hand side further by expanding this bracket, we have y plus data y will be equals to 2 times s square will be 2s square, 2 times 2s data s will be 4s data s, and 2 times data s square will be 2 data s square. So our expression is y plus data y equals to 2s square plus 4s data s plus 2 data s in bracket square plus s plus data s plus 2. At this point, we are going to subtract equation 1 from equation 2. Doing so, y plus data y minus y will be equals to 2s square plus 4s data s plus 2 data s square plus s plus data s plus 2 minus 2s square minus s minus 2. Simplifying, the left hand side becomes data y because y and minus y will cancel us, and in the right hand side we are left with 4s data s plus 2 data s square plus data s, because 2s square, we have 2s square, we have minus 2s square, we have minus s, and we have s, and we have plus 2, and we have minus 2, and they will all equate to 0. So what will be left is just 4s data s plus 2 data s square plus data s. Now dividing on through by data s, we are left with data y over data s will be equals to 4s data s divided by data s plus 2 data s square divided by data s plus data s divided by data s. 4s data s divided by data s is 4s, 2 data s square divided by data s is 2 data s, and data s divided by data s is equals to 1. So our expression simplifies to data y over data s will be equals to 4s plus 2 data s plus 1. At this point, we find the y over the s, and we know that the y over the s is the limiting value of data y over data s at data s tends to 0, which will be equals to 4s plus 1, because 2 data s will equate to 0 as data s tends to 0. Our final example is from November 2003. It states that find from first principle the derivative with respect to s of y equals to 3s squared. Solution. The first thing we are going to do is write down our equation y equals to 3s squared. And as usual, for every change in y, there's a corresponding change in s. So therefore, y plus data y will be equals to 3 in bracket s plus data s close bracket square. So simplifying our left hand side by expanding s plus data s square, y plus data y will be equals to 3 in bracket s square plus 2s data s plus data s square. We are still going to simplify our left hand side further to remove the bracket. Y plus data y will therefore be equals to 3 times s square is equals to 3. 3 times 2s data s will be 6s data s, and 3 times data s square will be 3 data s square. So our expression will be y plus data y will be equals to 3s square plus 6s data s plus 3s data s in bracket square. This will be our equation 2. Now subtracting equation 1 from equation 2, it becomes y plus data y minus y will be equals to 3s square plus 6s data s plus 3 data s square minus 3s square. The left hand side will simplify to data y because y and minus y will cancel out, and the right hand side will simplify to 6s data s plus 3 data s in bracket square because 3s square and minus 3s square will cancel out. So our equation will become data y will be equals to 6s data s plus 3 data s square. Now at this junction, dividing both sides by data s, we have data y over data s will be equals to 6s data s divided by data s plus 3 in bracket data s square divided by data s. 6s data s divided by data s will be equals to 6s, and 3 data s square divided by data s will be 3 data s. So our equation becomes data y over data s will be equals to 6s plus 3 data s. The y over the s is equals to the limiting value of data y over data s as data s tends to 0, which should be equals to 6s, because as data s tends to 0, data s is equals to 0. So the 3 data s in our equation will equate to 0, and we are left with just 6s. Therefore, the y over the s is equal to 6s. We have some exercises on this topic for you to attempt at home. The answer to these questions are found in our Hidden Facts Further Mathematics textbook, chapter 26. You can easily get it from the hard copy, or if you prefer a soft copy, you can get that at the website at the corner of the screen. Thank you.